Up next on Cycle of Health.
Tonight's topic, mosquito-borne illness. Tonight, two upstate docs describe their bloody good arboviral research. The County Health Commission talks trap and zap, and protecting ourselves at home and abroad. Slap. Yeah, got her.
This program is brought to you by the members of WCNY. Thank you.
Cancer. It's not just a diagnosis. It's a complex opponent, one that can alter the course of your life. Every move, every decision holds tremendous weight. St. Joseph's Health has partnered with Roswell Park, the region's only nationally designated comprehensive cancer center, to offer you access to personalized therapies and leading oncologists right in our community. Among the many moves you can make, this one holds the power to change your life for the better.
Hello and welcome to Cycle of Health. I'm your host, Dr. Rich O'Neill. Tonight's topic, mosquito-borne illness, West Nile, Triple E, Zika, dengue, malaria, and those pesky bumps that itch and itch, all courtesy of my least favorite animal after ticks, mosquitoes. Tonight, two upstate docs describe their bloody good arboviral research. The County Health Commission talks trap and zap, and protecting ourselves at home and abroad. Slap. Yeah, got her. Let's meet our guest, Dr. Katie Anderson, Onondaga County Health Commissioner. It's Dr. Stephen Thomas, Endowed Chair of Microbiology and Immunology at Upstate Medical University, and Dr. Adam Wakeman, Assistant Professor of Microbiology and Immunology, also joining us today from Upstate. Well, years ago, I went to Alaska to visit my brother, and I discovered in June, don't ever go to Alaska in June, the mosquitoes, they are like, no kidding, I'm not exaggerating at all, millions of them. Wherever you go, they swarm around you. You have to wear a head net to keep them. You can't have any exposed skin, and going to the outhouse is an absolute nightmare. So, how bad are things locally, Dr. Anderson?
So for framing, mosquito-borne disease is a huge problem globally and has been for centuries. And there are parts of the world where it's a major cause of hospitalization and death. Thankfully, that's not the case here, but we do have some important mosquito-borne diseases that we keep an eye on that can cause severe disease. And those specific ones for Central New York are Eastern equine encephalitis, or Triple E, and West Nile virus. Those are mosquito-borne viruses that the county is looking for with weekly trapping starting about now as we go into the summer months, looking to see how many mosquitoes are in our area, our numbers going up, and looking to see how many of them are infected with these viruses so we can take steps to try to protect people from getting infected.
So you trap them and then you see what nasty stuff do they have in them.
Yeah, so weekly our team goes out and they put traps at, I think it's about 19 different sites throughout the county, with most of them focused around Cicero Swamp, which historically has been an area with the most Triple E activity. Then weekly they go out, they collect all the mosquitoes from the traps, and at the height of the season it can be 15,000, 20,000 mosquitoes.
Whoa.
They identify them, they count them out, and then they send them off to a lab where they get a sense of how many of those were infected. And when the numbers get high enough, that's when the team will go out and do things like spraying, letting people know that we need to spray.
Uh-huh. How serious are these diseases, Triple E? Say it again if you wouldn't mind.
Eastern equine encephalitis, or Triple E.
Okay. How serious is that?
So they can be quite serious, and that's not to, in comparing the burden of mosquito-borne diseases in other parts of the globe. Thankfully, we have less people suffering from these diseases, but they can be very serious. So most of the time when somebody gets these viruses, they're likely asymptomatic or mild enough that we don't pick up the case. But when someone's diagnosed with Eastern equine encephalitis, for example, they go to the doctor, they're not feeling well, they have headaches, they could even have encephalitis or inflammation of the brain, which can be very serious. About 30% of those people may end up passing away.
Oh boy.
Now, it's relatively rare that it's that severe in this area, but we have had deaths. The last death was in, I believe, 2015, but we have cases, a handful here and there in even just the last few years.
So this is something you really want to try to protect yourself from, and the county does some things to protect us. When you said you spray, what that knocks down the population of mosquitoes?
Yeah, I think it's important to frame what the spraying means, because in my perspective, there's probably Eastern equine encephalitis circulating in our communities throughout all of summer, not just at the swamp. And we're only sampling at a few places, and we're only sampling a fraction of the mosquitoes. So I think it's safe to suspect that the virus is here in our community. And when we spray, it knocks down the mosquitoes that happen to be flying around in the air at that time, but it doesn't even get most of those populations. So the spraying is something that we do when we pass a certain threshold of saying, okay, now we think it's a significant concern, we'll spray. But in my mind, people should be going out when they're especially going to swampy or marshy areas. But whenever you're out in woodsy areas, taking steps to use DEET or picaridin, which would also protect you against ticks. And then the critical thing people can be doing at their homes is making sure that they're emptying standing water, because that's where the mosquitoes like to breed, and the larvae grow up, and then they can decrease mosquito populations around their homes.
So get rid of the standing water, get rid of those snow tires that you put in that have gotten filled with
bird baths.
Bird baths.
The ponds in the back of your yard that you may put beautiful ornamental water plants in, those are great breeding spots for mosquitoes. So keep an eye on them. You'll see these little tiny things swimming around, and those are the mosquito larvae.
Ooh. Well, most people don't know that Syracuse is an internationally renowned center for translational arboviral disease research. Our team visited Dr. Saravanan Thangamani at his state-of-the-art vector biocontainment lab at Upstate Medical University to see how mosquitoes are reared for research. Let's take a look.
The primary mosquito-borne illnesses that are of concern to the Central New Yorkers are the West Nile virus and also the Eastern equine encephalitis virus infection. These two are highly neuroinvasive viruses, particularly with a high case fatality rate, and they both don't have a vaccine. So prevent getting mosquito bites is the only way with how we can actually prevent getting infection from these two viruses. My name is Saravanan Thangamani. I'm a professor in the Department of Microbiology and Immunology and also the Director of Vector Biocontainment Laboratories at the Upstate Medical University. So Upstate Biocontainment Laboratory is where we actually conduct research on highly pathogenic viruses and bacteria that the NIH have deemed them as highly critical and important pathogens to investigate. Our human exposure suite is integrated into our vector biocontainment lab, and this is one of a kind. I don't think there are any other academic institution that can claim to have a human exposure suite like we have. People who want to validate their vaccines or therapeutics against a particular infection, they can use our facility to do preclinical trials. So mosquito-borne diseases are primarily transmitted once an infected mosquito feeds on a human and then transmit the virus. So the transmission process is very simple. When a mosquito is hungry to acquire blood, they normally land on a human body, wherever skin is exposed, and then they will try to take the blood. While they are taking the blood, they secrete pharmacological compounds to prevent clotting. If clotting happens while the mosquito is feeding, it is determinal for the mosquito, because once the blood goes into the mosquito, it clots inside the mosquito and eventually kills the mosquito. So to prevent that, mosquito spits certain anticoagulatory proteins while they're taking the blood. Along with that anticoagulatory proteins, the virus is also added or spit directly into the skin at the feeding site. That's how viruses are transmitted by the mosquito. We want to assess if a particular virus that is emerging, let's say for example in Florida, are they capable of infecting mosquitoes from Brazil? Are they capable of infecting mosquitoes from Thailand or Peru? So what we can do is we can actually infect the virus that is circulating in that area infect this into these mosquitoes, and then over a period of time, we will be collecting the legs, midgut, and salivary gland. And then we have a formula that actually calculates rate of infection, rate of dissemination, rate of transmission. So that is one kind of study we can do. The other kind of study, what people want to do is that if they have a vaccine, and if they want to assess the efficacy of the vaccine, and they want to actually use a natural transmission method to assess, instead of giving the virus via needle delivery, we can actually use those infected mosquitoes, transmit the virus directly to the immunized or vaccinated animals to assess their efficacy. So there are multiple ways how we can actually use infected mosquitoes to understand the basic biology of transmission and to evaluate vaccines and therapeutics as well.
What kind of research do you folks do?
So the viruses that the three of us and also Dr. Thangamani, we've worked on together for decades at this point, they're primarily dengue and Zika virus. So a lot of what we're trying to understand is why do some people become really sick when they're infected with these viruses? Why are some people protected from infection? And really what we can do, try to understand how we can break these transmission cycles and prevent the burden of disease around the world. Because as Katie mentioned, we have diseases like Triple E and West Nile here in New York, but other mosquito-transmitted pathogens such as dengue, Zika, chikungunya, there's these massive families of viruses that cause an unbelievable burden of disease all around the world. Dengue virus, which is the pathogen that's probably nearest and dearest to our hearts, there's an estimated 400 million infections every year with about
400 million?
400 million infections. With an estimated 3 billion people living in regions where there's the mosquito that can transmit dengue. So it is an incredible and growing health challenge around the world. And we're still developing and trying to learn more about what we can do to prevent and treat these infections. We don't currently have any antivirals or any drugs that we can give to people to actually reduce the duration of infection. There are vaccines that are being developed, but there's still, some of them are still early stage and some of them don't provide the breadth and durability of protection that we would want to treat and prevent the world. So there's a lot of research and a lot that we still don't understand, and a lot of what we're doing here at Upstate in Syracuse is trying to understand some of those risk factors and really generate and test those next generation therapies.
So is there any dengue in Syracuse? Does it ever appear here, or?
Not unless we give it to people. So one of the things that we
Not unless you give it to people. Well, aren't you nice?
I know. So we don't see locally acquired dengue here in Syracuse. We don't have the mosquitoes that are capable of transmitting the virus.
Thank goodness.
Thank goodness. We do have this is probably something Katie can comment more on, we do have a lot of traveler acquired dengue. I mean, we have people traveling all over the world that come to stay in Syracuse. And we do see a handful of dengue cases every year in the hospital here at Upstate. But one of the things, my little offhand quip about giving people dengue, one of the, I would say one of the crown jewels of our research program, our Arboviral research program here at Upstate, is a dengue human challenge model where we use a weakened strain of dengue virus to, and intentionally expose volunteers to this virus in order to test drugs, test vaccines, and really understand what an immune response, what your virologic response to an infection looks like in a highly controlled and highly safe setting, which is a program that really Stephen has stood up in.
Before you tell us about this, I want to know, is there a long line to get into this volunteer? Because I want to, this is not the, I don't even know, no thank you. Steve, tell us about this research.
Well, you know, I think, you know, your audience might be saying, that's great, they're talking about these diseases that are really in tropics and subtropics.
Yeah,
but
that's not what I've always thought.
Yeah, well, we have seen as ecology changes and climate changes, we are seeing places that are typically more temperate are becoming warmer.
Like the southern U.S., is there any dengue in Florida, for instance? Or?
Yeah, so every year around June, we start seeing the number of cases, both locally acquired and traveler cases of dengue, start to increase. And so, you know, last year in Florida in 23, there was almost 200 cases that were locally acquired, not just related to travelers. We've seen it in Texas, we've seen some in Arizona, Southern California. There have been outbreaks in Key West, outbreaks in Hawaii. And you know, the numbers aren't that big necessarily, but what it says to me is the ingredients are there.
Yeah.
The potential is there. The mosquito is there. We have susceptible people, and all you need is for the big 777 airplane vector to bring somebody in who's infected, or bring in a mosquito that's infected, and then it can start an outbreak. And we used to, I mean, probably one of the first and most comprehensive descriptions of dengue was back in the late 1700s in Philadelphia. So we used to have, before we had windows and screens and air conditioning and took care of things like standing water and whatnot, we used to have a lot of dengue and malaria and yellow fever in the country. So yeah, so we could revert back to that if we don't take some care.
Yeah, I was amazed. My daughter-in-law, my son, and his new wife went on their honeymoon to Thailand, and she came back with malaria, and I was amazed. I don't think they even anticipated, but there are, like, before you travel, you can prepare yourself for some of these diseases in advance. And
so there's more and more, thankfully, now you can do to protect yourself. But going to Thailand, where we've all worked for quite some time, there's a relatively high risk of dengue in particular, but also other mosquito-borne viruses like Japanese encephalitis, chikungunya, and there's now vaccines that may be appropriate for different travelers for all three of those things. Which is really important for people to know, and it's a reason to seek out pre-travel counseling before you take a trip anywhere.
So you can get vaccinated for those things in advance. And protect yourself that way.
That's right.
Yeah. And so you'd talk with your doc if you're going to go, or?
You'd make an appointment with the travel clinic, and the key would be to do that ideally several weeks before you take your trip.
The travel clinic is a county clinic?
We don't have a travel clinic, but our area has travel clinics. And then it would be a discussion. For a lot of these vaccines, they're not all the right fit for certain types of people. They're a great idea for other types of people, and so it's having the discussion about whether or not you should pursue those.
That sounds, for me, if I was going to be trying, I would definitely be going to check that out. So tell me about the human challenge model.
We do these things called human challenge models, where you can take a dengue virus that has been weakened. So it's not the same virus that comes out of a mosquito. It's been weakened, and there are ways that we do that. Same way we make vaccines, for example. But even though it's weakened, when you administer it to someone, that person can get a mild form of the illness, and they can have blood tests that look like they've had the illness, and they can have immune responses that are similar to the illness. And so now what you've done is, if you can consistently do this, you can now take a very small number of people in a highly controlled and safe environment and recreate what you might see out in the field, and it gives you a way to get an early understanding of whether or not this vaccine or this drug could potentially work. And you can do that before you have to go into tens of thousands of people all around the world and put lots of folks at risk. So it's a really good way to very early on kind of de-risk your development programs, and we happen to be one of the very few groups on the planet that actually do this.
You're an immunologist, so you get somebody infected with one of these weakened viruses, yeah? What happens next? What happens in the body, and what do you guys do?
That's a great question. So dengue is really interesting because most of the severe symptoms and most of the severe manifestations of disease happen after the virus is cleared away. So a lot of the severe, so it's often your own immune system that can cause some of the more severe symptoms associated with dengue infection. So what we're trying to, so what we're trying to understand is, okay, what does a mild dengue infection look like that results in an immune profile that we think is going to protect you from subsequent infection, and how does that differ from someone who progresses to develop severe disease? So can we tell early on, is there a signature, is there a blood test that we can develop, is there a saliva test or something that we can do to say, okay, you're at risk of developing severe disease, you're not, therefore we want to keep an eye on you, but not you. Because as I mentioned earlier, hundreds of millions of infections every year, only a small fraction of those people actually go on to develop severe disease, but we don't have any way at this point to be able to say someone's going to be fine versus someone's going to be needing to have supportive care in the ICU.
I mean, it's surprising when you dig into it, because they have been doing dengue human challenge experiments since 1902, even before. That's when the first you can find the first publication on this, and Albert Sabin of polio vaccine fame,
Yes.
before he accomplished that, he was in the Army around World War II, and he did a lot of research on Japanese encephalitis and a lot of research on dengue, and he did a ton of dengue challenge experiments. So this has been going on for a very, very long time. And dengue is just, I mean, it's one model. They have models for influenza, for malaria, for cholera, for lots of other, Zika, COVID-19, lots of different diseases that they have developed challenge models. And again, because you can, in a highly controlled and very safe environment, you can learn a lot and with less risk.
So those are called human, what did you call
Challenge
it?
models.
Human,
Yeah, human
challenge
challenge
models,
models,
yeah.
yeah.
And are they, you were saying before, there's something called mosquito feeding studies. What are those? Tell me about those. Is that what this is, really?
Well, it's a component of it. Because, I mean, obviously, mosquitoes are a critical component of dengue transmission. And
Yes.
a dengue, Zika, any of these arboviruses. But one of the goals or one of the desirable features of a vaccine or a drug is that you want to be able to block transmission. So if you are infected and you're given this drug, or if you're vaccinated and then are exposed, one of the really desirable features is if you're fed upon by a mosquito, did that drug or did that vaccine prevent you from transmitting that virus to the mosquito?
Yes.
So that's one of the things that we're going to be doing with this mosquito suite is, okay, for someone who has been challenged using this human challenge model, are you able to transmit that virus to the mosquito that is its natural reservoir, natural vector?
And to add on to that, so one of the big values of focusing in on the mosquito in these cases is there's one mosquito, one that's the primary vector for dengue, Zika, chikungunya, yellow fever. It's called Aedes aegypti, and it is probably the greatest public health threat to the globe right now.
Wow.
It spreads so much disease, and if we could find a way to better understand the immune response that the mosquito saliva causes in your body, so that's one of the experiments that we did, was when we had volunteers be fed upon by these mosquitoes and we could try to measure the immune response in their blood. But there are also people working on developing vaccines to Aedes aegypti saliva. So down the road, you wouldn't need a specific vaccine for dengue, you wouldn't need a specific vaccine for chikungunya. You could make it so the mosquito could not spread diseases to you anymore. So focusing in on this species is really going to be, I think in the future, I hope, a highly productive way to go about protecting humans.
That sounds wonderful.
Did you know mosquitoes have saliva?
I didn't know mosquitoes. I don't know anything about mosquitoes except when you slap them and your blood goes all over your hand, I just feel, yes, I got one. There's one less mosquito in the world. But too bad it got me before, because the blood is a bad sign, right?
You won the battle, but we were losing the war.
We're losing the war, yeah. And I understand if you let them fly off, you're less likely to get a bump.
I didn't know that.
I'll take your word for that.
I have researched that part, because apparently...
Well, that's something we can test.
Yeah,
which
something we can test. Yeah, but no, in this, so as the mosquito comes in to get a blood meal from you, as it's taking blood in, saliva and virus, as it's taking blood out, saliva and virus is going in, and in the saliva there are all these proteins, and these proteins can invoke immune responses, like Katie was saying, in people. And there's some research that shows that actually that's a really important part of why some people get very sick and other people do not get very sick. So it's all the different, this vector, virus, human host kind of triad. You have to look at all components. And we're fortunate that we work where we do, and we have all these resources available to us.
That is wonderful. Thank you for doing this research. So, and also, just very quickly, there are clothes now that are infused with permethrin that keeps ticks and mosquitoes and black flies and all these bugs off you, and that's what I am wearing, because I hate mosquitoes, and they work like a charm. You can launder them like 75 times and it doesn't go away. So anyway, that's about all the time we have. I want to thank our guest, Dr. Katie Anderson, Onondaga County Health Commissioner, as well as Drs. Stephen Thomas and Adam Wakeman from the Department of Microbiology and Immunology at Upstate Medical University. Finally, we have a tradition here. Laughter is the best medicine. I'm sure you're all itching to hear our jokes today. So, team, what do you call a mosquito short on her blood quota?
What?
I don't know.
A less squito. I happen to like that one. Knock, knock.
Who's there?
Who's there?
Amos,
Amos who?
a mosquito bit me. And knock, knock.
One more.
Who's there?
Annie.
And who?
And she bit me again. To hear our new companion community FM radio show, Checkup from the Neck Up, visit WCNY.org/communityfm. And for online extras, including our Checkup from the Neck Up vignettes, visit WCNY.org/Cycle of Health. For Cycle of Health, I'm psychologist Dr. Rich O'Neill. Thanks for checking in. Now you can buzz off. Bzzz.
Next week on Cycle of Health,
Tonight's topic, food allergies. 6% of us have them, and nearly 90% are caused by the same 9 food types. Symptoms include hives, swelling, even anaphylaxis. Kaboom. We'll discuss with our panel of experts how they're different from other GI problems, how to prevent, diagnose, and treat them.
Cancer. It's not just a diagnosis, it's a complex opponent, one that can alter the course of your life. Every move, every decision holds tremendous weight. St. Joseph's Health has partnered with Roswell Park, the region's only nationally designated comprehensive cancer center, to offer you access to personalized therapies and leading oncologists right in our community. Among the many moves you can make, this one holds the power to change your life for the better.